All right, guys, this video, we're going to take a look at two different things. Um, we're going to look at when we throw a negative out in front of all these basic shapes, how it's basically going to flip over, or you could say around the x-axis. All right. And if you just kind of read through this, the first part says if you multiply any basic shape by a negative number, it's going to turn the graph upside down. All right. So A is that basically it's the leading coefficient. For these ones, if you look at all of these are 3 out of the 7 basic shapes. And for all of these, the A value is 1. So it keeps its same shape. Now, when we actually go down to these, all 3 of these, and I'll move it down so you can see the whole graph. For all these 3 that I just circled, the A value is -1. So these graphs are just going to flip over the x-axis. This flips this way, right? If this would flip up and then come down. And then these, the boomerangs I call, they would flip, so it would be top left, bottom right. And when I move down, you see that's exactly what we get. All right. So, and you probably have seen that before. So you just take the original graph and you just flip it over the x-axis if there's a negative. Now, the other thing it says here, the width is also changed. If we change the A value, you're going to see like some of these parabolas or V shapes, they're going to get wider or they're going to get skinnier. That's going to be on the next page. Here, we're just dealing with it. If it's negative, it's just going to flip over the x-axis. And I will do one example, which we don't see a whole lot of where you would put the negative, and it's actually going to flip over the y-axis, not the x-axis. But for the most part, we'll just deal with flipping it over the x-axis. All right. So you can see how these graphs just flipped right here. All right, so it's always good knowing the basic shape. As soon as you see that negative, just flip it over the x-axis, it's upside down. All right, let's look at some other examples. All right, okay, I'm gonna skip. The first example is real simple, the lines. I don't even think I need to waste time going over that. If I did this, the next one, I have a negative in front of the square root of x. Well, the square root of x, I always like drawing the parent function first. It just goes up and to the right. So then when I do the other one, it's just going to flip over the x-axis. It's just going to look like this down low. So it's still going to start at 0. Now, another good point to plug in is if you have 1, well, square root of 1 is 1, but you have the negative, so it's 1, -1. So that proves it goes down low. Right, so that's our graph. I would also be doing domain and range for all of these. I'm just going to skip it for now, just so I can get through more examples. If I did the next one, the absolute value, well, absolute value really just looks like this. It's the V. So now the absolute value is just going to go upside down. It's just going to be this. And we would have 1, -1 would be on here, and -1, -1 would be on here. All right. I'm going to skip. I'm going to do this one last and really tie it into that because it's the same function. Let's do this. This is the boomerang shape when you have the x squared and it's in the bottom. Now, normally, the boomerangs they're both above. But since we have this negative, they're going to flip, and they should go like this. All right, we're going to have the same VAs, the same HAs. Now, good test is if I plug in 1, well, you would get -1 over 1 squared, which is -1. So that proves it's down low. And if you plug in -1, you're going to get the same thing. -1 squared is +1. -1 divided by 1 is -1. So it's the Atari shapes that are down low. All right. Okay, now the one that I starred right here is, notice how I have the negative inside the square root, where this one, the original, where it flipped over the x-axis, it's on the outside. If you have a negative on the inside of the grouping symbol, in this case, the grouping symbol is the square root, it's actually going to flip over the y-axis. So what would actually happen, you still plug in 0. Now you can see you cannot plug in positive values for x because you would get the square root of a negative. And we can't take the square root of a negative. So I can only take the square root of positives. So therefore, I have to plug in values that are negative for x. So it's going to go to the left. It's going to flip over the x-axis. So if you were to plug in -1, the negatives would cancel, and you'd have square root of 1, which is 1. So this would go to the left. All right. So I'll just put this in your notes here. Most cases, if you have a negative on the outside of the function, I'm going to say it flips over the x-axis. All right. Now, if you put a negative kind of inside the grouping symbol with the x, then we say it flips over the y-axis. And we won't see this happen as much. Flips over the y-axis. All right. Okay, let's go to the next part. This is where we're going to make the graph wider or skinnier. Again, it has to deal with the a value, the leading coefficient. All right, so if we, and it kind of spells it out for us. So say when a is greater than 0, the width of the basic shape changes. Here's kind of the main thing, rather, so I don't just have to just regurgitate everything that's up here. If you have a, generally speaking, here it is, if a is bigger than 1, the graph rises or falls more rapidly, it's going to get skinnier. If a basically is a fraction that's less than 1, the graph rises slower and it's going to get wider. All right, that's the easy way to remember it. So if I were to look at this example, we're going to get a parabola. So you're still going to have this vertex right here. You can even see the a values too. It kind of acts as your slope. So the trick is, whatever the a is for a parabola, is when you go to the right, when you move over 1 unit, it could be right or left, you're going to go whatever this a value is, and in this case it's 2. So I go to the right one up 2, I go to the left one up 2 from that vertex. Right? This is what you would get if you were to plug in -1 and 1, you would get it to equal 2. All right, so it's going to get skinnier. Now, the next one, you could see the S curve. You could see this one. This is where it's going to get wider. So you have the same middle point at the origin, but now when you go over 1 unit to the right or to the left, it's only going to go up or down 1/2 unit. Right? And it's these points right here. All right. Let's just go to other examples here. All right, let's see here. Let's take a look at the second example. So the second example, first thing you always should identify is the basic shape. Okay, since the x squared is in the bottom, that kind of stands out. This is the Atari shape, where they're both above. Now there's no negative in front, so it's not going to flip. But this a value of 3, that means this graph is going to rise above the HA a little bit quicker. So we're still going to get, not the, yeah, the HA is still y equals 0. The VA is still x equals 0. What the a value does is if I plug in 1 for this, you're going to get 3 over 1 squared, which is just 3. So there's a little bit more of a gap between this point and the HA right here. And if you were to plug in -1, you get the same thing. 3 over -1 squared is still going to give us 3. All right. Let's see what else we could do. Let's take a look at this one. Now this one's the V shape, but since the A value is 1/2, it's going to get wider, right? It's a fraction, it's less than 1. So you're still going to have this vertex at the origin, but now that slope's kind of like 1/2. So when you go to the right one, you only go up 1/2 a unit. It's like right there. So that's 1/2. Oh, trying to squeeze it in. And if you go to the left one, you only go up 1/2 a unit. So that point's -1/2. Okay, connect it, and we have our domain. Again, I'm kind of skipping domain and range, but we should always do domain and range for all of these. Let's see here. What other one can we do? Let's do one more. Let's do this one. So this one's going to be an S curve. Now that middle part where it kind of changes its shape for the S curve is still at the origin. Now since the A value is 2, it's that S shape is going to go up quicker, so it's going to get a little bit skinnier. So that's kind of our slope. So from this middle point of the origin, when we go to the right one, we're going to go up 2 because that's the A value. And then when we go to the left one, we go down 2. So this point's what? 1, 2. And then this point down here is -1, -2. And if you were to plug 1 and -1 in an XY chart, you would get that. You get the 2 and the -2. Now it looks like a line, but make sure when you draw it, it's an S curve. Kind of change its shape around the origin. All right. So really to kind of sum everything up here, the first page, if you put a negative in front, you take the original basic shape and you just flip it over the X. We did the one example where it flipped over the Y. And then this, if the A value is bigger than 1, like it is in this case, the graph's going to get skinnier. If the A value is a fraction and it's less than 1, like this case, then the graph is going to get wider.